This slide is about the tensor product, and here we go. It's quantum computing algebra, linear algebra about tensor product means what? The outer product means that is k times bracket and means that this change the position. The different operations, the outer product of two vectors is a specific case of the more general concept of the tensor product. It's a specification, and the tensor product is a more general concept. And it's the notation is about the circle with the x. Oh, what is the tensor means? Tensor is just like outer product, but it's used. It's very easy because it's just like some computation, some combination of different matrix, different vectors to be a new form. I think the basic principle for tensor product is that we don't change the basic shape, basic value. What is the meaning of tensor? Tensor means that we just enlarge in some dimensions, but if we maintain the original information about each two element, I think it's a little bit like a convolution. What is the size of the conduct? A times b times c, I think means what? A times t times b times d. That is how can we understand A times AC times BD? So AC times BD, so that means each element in the first is just the just like a scale to the second, and so the set series means what? Formally, set theory, what's the beginning point to talk about the set theory? It's about the Cartesian product is the most classical and the traditional point. So what is the Cartesian product? It means that our two sets is defined that as t. For example, if we take two sets to be 1, 2, 3, 4, 5, so the Cartesian product is another combination that it's just like a bit of like the tensor product. So let's come for it's just a combination. So x times t is promised 2 to 3, and so what is the R, N, and Cn notation means? I know functions. A function is an ambiguous assignment of each element one array to another set, one set to another, etc. The circle relations, definition of relation on two sets, x and y is a subset of Cartesian product. Oh, I just think this video, the one content, I can't guarantee the quality, but I think the content is one of most important in my video. Okay, I just can't say this. A function is a special case of a more general phenomenon. Function generalization means it's a relation on two sets, then is a subset of their Cartesian product. Subset of Cartesian product. relation to a relation is the subset of the products which condition they are to the subset. By definition, R is the relation since it's a subset of Cartesian products. Our terms are of the real or the set of real number R with itself. But what is it? The following are examples of points which are elements of R, and you should look like this. Oh, it's a little bit math and a little bit difficult to understand. I hope I can do something. The following are example. The subset, the relation, Y relation is a subset. What is the relation? Relation means a subset of Cartesian product. Cartesian product means that it's just a operation, a set of operation, a kind of operation, and the R is the relation, the subject of R times R. It is a subset of the Cartesian products R times R. That a real number is defined. What is it? It is like definition of function, a relation with the product is a function if and only if there's the sum. Basic definition about function means that we just need to only set one to one, not one too many, not one too many. Yes. Injective function. Injective means that it's never maps to differences in one injective, and so this one to one, not a multiple to one or one to multiple. Surjective and bijective means that fx equals to 1, there is a surjective. This is basic and bijective that it can be inversed. I think invertible function means by another person what is this, but function relation is a little tricky. Composition means that this is a composition function, and from high school and middle school and the first year in the university, I think this are just something that I can see, but I don't understand the back of this thing and the deep meaning. I should dive into them, but I think now I just know about its shape. And the linear transformation, that definition of linear transformation, I think I should to be able to define them precisely rather just know about them. So there are two types of the definition, two formula describes this. Vector space means that a vector space over field is a Abelian group V equipped with an action of the field F on V. It is a space where a bunch of vector lie. A bunch of this set, I think groups means that satisfy the following properties. That is, in group means that, I think 10 days later I will go to the math competence. I hope this can help me a little about some mathematics. Associative. There are just some group is a set of following properties. That is, the group means that I have these four. That is closure, associative, and identity, and inverse abelian abelian group means that a group called if and only if cumulative rings is the abelian group with an additional operation called multiplication. That's it. The additional conditions associated for rings. Okay, I don't know them well. Addition which is often multiply that satisfies some additional rings, fields, the definition of fields, action of fields, and vector space is that they have some properties. I think there are 8 rules, but there are more than 8 rules. So these are some basic laws for us to discover. Oh, too many information for me to control. That I just share with you. If it's not, it could be shared. I don't hope one day this will be cancelled or to be banned to display. Subspace, subspace, subspace is just subspace lemma, or that's the closure. Oh, I think it is very important for the let's start remember. I think closure associative identity inverse this for closure means that associative means the associative identity means that we can something like one inverse means that one thing I think is very important and that notes from a mark. Friends, I think subspace and the subspace man lemma and the definition with linear transformation span linear independent spaces and dimensions. What is spanning set of vectors, span of set of vectors, and linear invariance? Okay, my spot is very little bit wrong. Linear independence means that we can do something that can be there are something that can be represented by the similar thing. Basis and dimension. Dimension is what is the number of vectors for any basis for weight. Also normal. Linear transformation. So there are many transformations. 3 blue, 1 brown, 1 and operators. The determinant, I think determinant 3 by 3 and the invertible. Something inversion. Okay, to be honest, I can't deliver more information about this expression. I just think they are just some basic mathematical operations are the additional thing is that there are some geometry representation and just thus and now I don't want to dive into it too much. Just some tools I think. Educate matrix, educate matrix. Find the inverse and in matter as matter. This is linear algebra basics. Okay, I think I have nothing to share with you, only this slide. I hope one day I can share with more the deeper thoughts. But nowadays, just some basic operations, conjugate, symmetry, linear product, positive definition, and conquer delta function, conquer, and the Hermitian operator. Oh, I think this should be knocked to the blackboard. I think Hermitian operator. Join into the matrix. Into a Hermitian self-adjoint in the conjugate transpose, unitary. These are something that I'm not familiar with, just scanning keyboard space. Oh, just. Oh, so difficult for me. Thank you very much. I think I need more effort about these slides.